This tutorial is on writing formulas of the compound from the name of the compound. Writing formulas of a compound from its name is the first step in writing chemical reaction equations. First thing you need to do is to decide whether the name is going to be an ionic compound or a covalent compound. If it is an ionic compound, the first word will either be ammonium, the polyatomic ion NH4, or a metal. And then the second word will be nonmetal, or a group of nonmetals, a polyatomic ion. Now, if both words are nonmetals, then you have a covalent compound. In this case, we have carbon, which is a nonmetal, and monoxide, the oxide stem is for oxygen, which is a nonmetal. So since we have two nonmetal elements, we have a covalent compound, which means that the formula comes from the prefixes on the name. So carbon does not have a prefix. Whenever you have a covalent compound name that does not have a prefix on it, that means 1. And then oxide stands for oxygen, and it does not have it has the prefix mono, which means 1. So we have 1 carbon and 1 oxygen. So the formula is going to be CO. And we don't write the ones in chemistry, so CO is the final formula of carbon monoxide. The next problem is copper 2 sulfate. Sulfate, the ATE ending tells us we have a polyatomic ion. So these are a group of nonmetals. However, copper is a metal. So we have a metal plus a nonmetal, we have an ionic compound. So what we have to do is crisscross their formulas. So copper is a 2. Since it's a transition metal, they give us the ion charge in the name. So Cu plus 2. Sulfate is a polyatomic ion of SO3 with a -2 charge. 2 nonmetal atoms bonded together that have a charge. So we crisscross. The 2 goes to the sulfate, 2 from the sulfate goes to the copper. We get Cu2SO3 2, and then since they both have 2's, they're going to cancel each other out because we must reduce them. So copper sulfate is CuSO3. Our next one is calcium chloride. Calcium is a metal. It's in group 2 of the periodic table. Chloride, the IDE ending, that's how we name the elements that are nonmetals when we put them in a compound name, so that is chlorine from the periodic table. Chlorine is a nonmetal, and calcium is a metal. So since we have a metal and a nonmetal, we have an ionic compound. So we have to write the ion charges. Ca with a +2 because it's in group 2 of the periodic table. Cl with a -1 because it's in group 17 of the periodic table. We crisscross their charges. The 1 goes to the calcium, the 2 goes to the chlorine, and we get Ca with an invisible 1, Cl2, and there's no need to reduce because it's already at its lowest ratio. So CaCl2 is the formula for calcium chloride. Next we have oxygen. Now when you have a nonmetal that is by itself and it's one of the diatomic 7, it is going to always be bonded to another one of the same element. So if you look on the periodic table, remember the diatomic 7 is nitrogen, oxygen, fluorine, chlorine, bromine, iodine, plus hydrogen. Oxygen is one of the diatomic 7, so it can never be just O by itself. It will always be an O with a 2. O2. So any of the diatomic 7, when you get just their name, then it is going to be in its diatomic form with a 2 after it. Our next one is diphosphorus pentoxide. Diphosphorus, phosphorus. It is a nonmetal, and oxide is the oxygen stem, so oxygen is a nonmetal. So we have two nonmetals, so we have a covalent compound. Now our prefixes tell us how many. The prefix di stands for 2. The prefix penta stands for 5. So we have P for phosphorus with a 2, and then O for oxygen with a 5. Now you never, ever, ever, ever reduce your covalent formulas. They are exactly as the prefixes tell you to, and you never reduce them down any.